To the module on speech recognition. The first task that we need to complete is to get a computer to understand spoken language. By understanding, we mean that the computer must react appropriately to what it has heard or convert the input speech to another medium of communication like text. Let's dive into how we might be able to achieve this. Now, how do humans communicate ideas through speech? We produce sound waves which the ear conveys to the brain, and the brain finally interprets the meaning of the sound. In case of computers, the sound wave is converted into an electrical signal with the help of a microphone, which is then sent to the processing unit of a computer to try and interpret the meaning of the input speech. Automatic speech recognition is used to derive a sequence of words from a stream of acoustic signals. A general flowchart for any speech recognition system is shown here. First, a feature is extracted from the speech signal, then the pattern is matched with reference patterns. After which, appropriate words are suggested based on how confident the system is about that result when compared to other possible results. Many types of automatic speech recognition techniques are in existence currently, and each has its own decision and pattern comparison rules. Let's have a look at some prominent ones. In the template-based approach, the system stores examples of units, which could be words or phonetics, and then find the example that most closely fits the input speech. One format in which audio signals can be stored is a spectrogram, which is a visual representation of the spectrum of frequencies in the audio signals. So, the system could store spectrograms of words spoken by a user and compare inputs from the user with the stored spectrograms of different words. As an example, can you identify which of the 4 spectrograms of the word science were spoken by the same user? The bottom 2 spectrograms look similar, hence you could say that those words are spoken by the same user. A disadvantage of this approach is that one might have to store templates for different users, and the computer's capability to understand a user's speech is limited to the number of stored templates of that user. To overcome these limitations, templates were replaced by rules based on our knowledge of a language. At each decision point, these rules will be used to predict the next set of sequences that are permitted in that language. This approach has limitations as well, since there is difficulty in expressing rules and making the rules interact with each other. The third and commonly used approach is a statistical approach known as the Markov model. Let's have a look at how this model works with an example. Markov chain is a probabilistic process that relies on the current state to predict the next state. For instance, if we know that the current state of weather is cloudy, there is a 10% chance that the weather will remain cloudy, or a 50% chance that the weather will be rainy in the next state. Similarly, if the current state of the weather is rainy, there is a 60% chance that it will remain rainy, or 10% chance that it will be dry in the next state. These probabilities expressed in the Markov chain can also be expressed in the form of a transition matrix. The transition matrix transitions from row to column. Now we have another vector table which represents the current state. By multiplying the two tables, we get the probability distribution of the next states. In the resultant matrix, you can see that the probability of rain being the next state is more likely. You can further multiply this matrix with the transition matrix to find probability distribution of the next states. What you saw previously is a Markov model where the current state is known and there is only one sequence. Models where there are multiple sequences possible are called hidden Markov models. In such models, the current state of the model may not be known, but the parameters on which each state output depends on is known. This model is commonly used in interpreting speech by running through all possible sequences and statistically choosing the most probable one. Nowadays, machine learning models are used to train computers into recognizing features and patterns in sound all by itself, using which they can predict results of speech input. There are a number of challenges that we face in the process of speech recognition, such as efficient conversion of the analog sound signal into digital format by prioritizing the frequencies which are more informative, separating speech from background noise while processing the speech signal, variability in individual speech such as pitch, loudness, voice quality, and accents, language fluency, etc.